So let's see if I'll try and correct this on the slides next time, sorry. There you go. So you can see that's the intercept, that's the stand LRT. And you can already sort of gamble from this that it has a large value and a small standard error, that it's going to be significant. And if you know something about t-values, you should know that that's quite a high t-value. So even though you don't have significance tests, you can already infer some things perhaps from those statistics. And yes, that's the most important bit you need to know. So you can also have variables on the group level. So you remember school average. We can also incorporate that in our model, and we can so it shouldn't be the size of the school. I thought it was the size of the school, but it's basically the average intake score. So I need to correct that. So it's not the size of the school, but it's the average intake score. Yeah, so it needs to be the same length. So for every unit on the lowest level, the group value. So it basically means if you have your data, that those values need to be present for every individual also. So it's basically, you'll have lots of repetitions because they went to the same school, but it has to be, you have your data at the individual level, and then you build these models. So you need data so this will be 4,000 lines of data, and then some things will be the same because they're all the same for the same school. Like for example, school average. So now we have stand LRT plus school average plus one stand. So this is here we've just specified explicitly. You don't always have to do that, but it's by good practice to say we want an intercept. Sometimes in earlier versions you had to always explicitly say it. So this just means have an intercept as well as the random slope. And you won't be able to see again, so I'll just show you what happens further down. So here you have the school average thing, and so you have their t-value and estimates as well, and then you would do model comparisons to see if those effects are significant for school average. So you could compare this model to one with just standard LRT and see how much better or how much worse it becomes. Yeah. Good. The most important thing is I have to show you the code here because it overflows, and I didn't manage to fix this this bracket, so it just keeps on that. And this has nothing to do with R; it has everything to do with RStudio. So it's just very unfortunate. So just to show you what it looks like. So that's the full code, and I'll upload you just a regular HTML file so you can see it. It's to do with how the slides are made. There's nothing to do, so the code is correct. It's just that it can't print everything on the line. So even though if you're smart, you might have seen this. So this tells it to cut off after two things, but RStudio and overrides these type of settings. So it should cut off at this thing and start a new line, so you can all see the code running through. But it doesn't do that. So and I've emailed lots of fora, and I don't know. So. But this is specific to presentations, so it's not something that applies to your assignment. So you remember Stargazer, so we can use Stargazer to build, to take those models. And we can, so that's basically what it does. So we have a null model, we have a model with stand LRT, we have the model of school average. We want to export an HTML table. We want to label the R-dependent variable as scores, so you could call them standardized exam scores or something along those lines. Now we can put in also the covariate labels like London Reading Test and school average, because those correspond to those type of fixed effects. And then we can pick a style. So I picked demography. There's other styles you can pick, and that will make us a nice formatted table in the end. And the out would be multi-level models, and we don't want a special header. So those are all the codes which by now you should be becoming more and more familiar with Stargazer and what it can do. And if not, look at the vignettes. And this will give us some nice type of formatted HTML table. So here we go. So here we have our models summarized quite nicely. So you would do probably 4 or 5 models, and then very good readers will be able to see that the EIC changes or goes down. So you can see this one is if you're a Bayesian, you don't believe in school average type of effects. If you do AIC, you would believe because you're going 4 units down, which is quite still a substantial shift. So you would say school average doesn't matter. So the stars correspond to p-values. So handily, it does print stars, which you might need for your report. So you can see significant effect for London reading tests. It doesn't change when we add the school average in. It goes slightly down, but it's 0.057 to 0.052. Those things between brackets were the standard errors which you saw in your table, yeah. And you can see this is a significant effect, but not it's at 0.01, but not at 0.001. And so this leads probably for the Bayesian. If you're a Bayesian, you would say that's not a lot of improvements. So this model is better because it has a lower BEC. But if you're into p-values, you would say it's a significant effect at 1%. So we should keep this. And also this model has the lowest value in terms of AIC. So sometimes the decisions which you take depend on your prior beliefs and what you think is a strong or weak effect. So because you should also bear in mind, here you have 4,000 cases. So a p-value of 5% is quite impressive if you have a small sample size. But if you have a very big sample size, small deviations will give you significant effects. So you could say, I'm only going to look at things where things are highly significant because we have 4,000 cases. So in that case, you might favor the second model rather than the third model. So you can also see that it printed scores nicely, and so it's a nice formatted table. So again, one of the benefits of using R is that you can get these type of formatted tables directly from your results. And so if you build lots of models, and then it has printed everything correctly, so you don't make any copying errors from like putting it in Excel and then putting it somewhere else. This is exactly as the models were when you ran them. Yeah? Any questions? And so it will print all this gibberish, which is HTML, in the actual slides. Now we come to the point where perhaps this should have come earlier, where you get to try it yourself. So I'd like you to load the ScotSec package from the dataset from the MLM Ref package. It has scores from 3,435 Scottish secondary schools on a standardized test taken at age 16. And both primary school and secondary school have been, which the student has attended, has been recorded. That's the paper. But I would like you to just focus for now on looking at the second school level. So build on test a null model with a random intercept at second. So that's referring to their secondary high school, and attain as a dependent, which is their score on the standardized test. And then I would like you to build a model with a fixed effect of verbal and a random intercept again at second, and attain is dependent, and compare that model to the null model by the ANOVA command. And then I would like you to build a model with a random intercept plus a random slope, and compare that to the null model, which would just, at this stage, oh yeah, make a plot. Don't make a plot just yet. You can make a plot if you want to, but it could be tricky. But I've shown you how to make a plot of the random slope and random intercept. But if you can't manage, don't do this. So depending on the type of thing you're comparing, you have to use either ML or RML. Yeah. So for this one, we're looking at a comparison between random intercept and random slope versus a random intercept model.
It won't let me download that one.
No? Let me just have a look. Why is it not?
Because I've got an old version.
Is it an old version of R? Okay, so let's see if we can get it in another way. Are you able to download it?
No.
We have old versions of R perhaps, or older operating system. Let's just see if it's if I put in the command correctly. So it's MLM ref, and just the R is capitalized. That's cool. Yes, that seems correct. So 3 is not available. So let's see if we can. So that's the Are other people able to download it, or so it could be? It's quite an older package, so it could be due to that. So and if you have a more recent version of R, if you recently updated it, that's causing some problems. But I'll see how you can get it this way. So if you try to install the correct package, MLMRef is a subset of that package. So you try and install that. Correct, like this. And then it will try and install MLMRef if you can. Then it should install the dependency, and one of them should be ML and ref. Down. So it's download it, and then you can see if in the correct package you also have the exam data.
Aye.
So if you open the correct,
That one is
just on the right hand side you can see in the library the task and exam data present. And if not, I'll see if the data are anywhere else. Go to E. So you guys are exam data. No. I'll see if I can find where else the data, because usually the data sets are stored in many different
Mine
packages.
doesn't let me download all of these.
Okay, so that probably means that you need to update your version of R. It's quite important. So I think you're 3.3 and these versions are 3.4 or something. So sometimes you are not compatible anymore because the package is updated, but your R environment is not updated. So that means you have to update it at some point. So I'll check if I can. Once imagine compiler.
Oh, second. Because that's for second.